So hello, and thank you for joining us for another exciting InRhythm Lightning Talk. I'm your host, Ted Parton, and I'm a tech community evangelist here at InRhythm. As always, every week we have a Lightning Talk at 5:15 Eastern on Thursday afternoons. And this week is a really exciting one on finding memory leaks by our own Takahiro Ninomiya. And he's one of our iOS engineers. Excellent guy, and you're in for an excellent treat. I got a sneak peek of this the other day, and it's got some wonderful graphics. With that, I'm going to hand it on over to Tak.
Thank you, Ted. Good evening, everyone. Thank you so much for joining today's Lightning Talk. My name is Takahiro. I'm a InRhythm iOS developer. In today's presentation, we will explore memory leaks in the impact on the app performance and the user experience, and how we can effectively address them using the XCode tools. What are the memory leaks in the iOS and Cocoa? Memory leaks occur when allocated memory is not properly released. This can happen due to the unreleased memory allocations, which accumulate over time. The iOS Cocoa frameworks use the automatic reference counting to manage the reference counting of the object automatically, but the issue can still arise with it not used correctly. One common issue is retain cycle. Retain cycle is a situation when objects hold strong reference to each other, preventing them from being deallocated by the automatic reference counting mechanism. As a result, memory allocated with this object is not being released, leading to the memory leak. Why should we care? The memory can lead to unexpected behavior in your app. For example, it can cause content to not read or silently updated data locally and remotely, resulting in future not working as expected. At the end of the day, it could leave the bad impression of the app or service. There are two major helper tools that are introduced by Apple to resolve the memory leak issues, which works along with the Xcode. One is Instruments Performance Monitor. The Performance Monitor is the tool that can be used to monitor and analyze the performance of your app, including memory usage. It allows you to view real-time information about your app, memory usage, including total usage of memory and the usage of individual components of functions. By monitoring memory usage with the Performance Monitor, you can detect any usual memory usage patterns and investigate any areas of concern to identify memory leaks. To access Performance Monitor, navigate the Xcode menu and Xcode and open the developer tool, the instruments, and then search for the leaks. Once you have opened the leaks, you can start tracking memory usage by clicking the record button. The other powerful tool is Memory Graph Debugger. The Memory Graph Debugger is a tool that in Xcode that helps detect memory leaks by visualizing object relationships in the app. It displays object information such as class name, memory address, and then retain count, and can detect retain cycles. It's by using this tool along with the other Xcode tools like Performance Monitor and stack logging, developers can easily locate and address the memory issues. To open it, run your app in the Xcode debug mode and click the debug mode, the debug memory graph button in the debug mode. The live demonstration. Today, we will be doing the live demo to show you how Xcode Memory Graph Debugger can find memory leaks in the project. This project has 3 view components, a content view and 2 memory views, which UIKit view and Swift UI view. And both UIKit view and Swift UI view will print debug strings when they're created and then destroyed. So you can see that happening on the console as well. And content view, the root view uses the stack navigation to push the 2 types of views. When views pop, it should be removed from memory since we are using the navigation stack. And we should see the date in the console. In the UIKit view, it has a UIV controller and bunch of service nodes connected to a linked list. Each service node has an observer property. And then controls the multiple service nodes to the linked list and then sets the last node of the service nodes observer back to the service linked list. But there's a problem. This linked list and the service nodes has a retained cycle. Like this image, the service nodes observer has a strong reference to the linked list here, causing circular references. And as I operate it, let me show the console. If I operate it, init shows. As you can see, even popping the UIKit view, the init isn't printed in the console, so we've got the memory leak. So now let's open the memory graph and see how it captures the retain cycle. But before opening the memory graph, let's turn on the malloc stack logging, which this feature collects all memory allocations and the allocation history in the app sandbox area. It helps to track down the exact where the object has been created and in the memory graph. To open it, go to schema and diagnostics and check the malloc stack logging. And make sure to choose the all allocation and free history. And close it. And with that enable, let's run the app debug mode again. And then do the manual test, push and pop. Push, pop, still debug with date is not being printed. So let's open it and memory graph. So in this graph, the left pane displays the active object that are being kind of retained. And you see the object with the yellow triangles here, which indicates the leaked objects. When you select one of these objects, it shows the objects that are referencing or being referenced by connected by the arrows. This tick arrow represents the strong reference, and then text on the arrows. It shows the name of the property or entry name of the object. Also, on the right pane, you also see the details about the object and its reference, which is, for example, the service nodes, the property name observer is strong, a linked list, the head is referencing the next first service node. As I mentioned earlier, last service node is strongly referencing the linked list and through its observer property. So let's go back to code. So let's add the weak hint. Oh, this one. Excuse me. To the observer, to the target entry of the to address the memory leak. Now state became linked state became a strong to, since we added the weak, became a weak. And now retain cycle involving the UIKit view should be fixed. So let's retest manually. Clear the console first, and then push, pop, push, pop. As you can see, the init is printed, which means we've successfully resolved the memory leak in this UIKit view. And then also from the memory graph, you also notice that there are no retained object left. So the memory leaks being resolved. You could see it from the, you could confirm it from memory graph debugger as well. So now see the other view. Safety UI view. So this view also has the memory, but the architecture of this view is the view has the view model, very simple, and the view model is posting the timer publisher. The picture is like this, image is like this, has a timer publisher, and then views when it's appeared, it kicks the timer, the start, and inside of the start, the timer publisher elapses the event every second. And then timer is being updated. But inside of this view, the self is strongly referenced, so the retain cycle is being created. Oh, this one, yeah, sorry. So the self is strongly referenced here. So the retain cycle, there's a retain cycle. So to address this, we want to give the reference hint as a weak. So the self will be weakly referenced. As you can see from the manual test, even pushback, the init is not being printed, so the memory is occurring. So let's see the memory graph, open the memory graph and how it captures. Let's see how it captures. So like the previous operation, that you could find the leaked view models on the left pane, but the retain cycle is not being isolated from the root referencing chain. So in this case, you will have to find them by following the reference hierarchy, the tree chain, manually. this case, this is the leaked view. So just opening this, and then view model is referencing the any cancelable, and also creates the sync. And then sync is referencing the view model again. So the same pattern is repeating here. As we found that tree is repeating the same pattern, so the retain cycle is being witnessed. So as previously I stated, the reference arrow is referencing the object name. But some cases, such as the project gets larger, the referencing this name might not be accurate. So in that case, select the object nodes, the referencing the leaked object, which is referencing the view model, so which is the sync object. Then see it on the right pane. Since we enabled, Malloc stack logging, you can find the location stack trace in the right pane here. So then from the arrow icon, can you see it? Tiny arrow, yeah, here. That helps to jump the exact location the object is being created. So this can also help locating the retain cycle. So now let's add the week in here. And escape the routine as early state as possible. And then small tips that if you're writing the code in the Swift 5.7 or above, the smart unwrapping is being introduced so that you don't have to write in the guard or if statement to unwrap unwrapping the object. Just in this case, you could write the guard itself and return. And let's rerun the app. Timer counts in it, stop daily in it, and stop daily. So now, as you can see, daily is printed, which means we are successfully resolved a memory leak in this UI, Swift UI view as well. From the memory graph, let's see how it shows. Also notice the leaked view model is gone, so the no retained object is being left. So now we resolved all memory leaks regarding this project. That was a demo. But before I finish this project, please keep in mind that if you set Malloc stack logging is being enabled, make sure it's been disabled. So this check, as I previously stated, this check records that all stack logging accumulates inside of the app sandbox. So the size of the app gets bigger and larger and eats up the disk space. Yes, that was the memo. Thank you. Demo. Thank you. The summary is the memory graph debugger offers the clear visualization of the. Today we use the memory graph debugger, but that too can offer the clear visualization of the object relationships. And when combined with the stack logging, it helps to precise the leak identification. And also remember, disable the stack logging check before finalizing the project, preventing the unintended issues. Thanks for the attention. Any questions? If anyone has additional tips or insight, feel free to share them as well. It's always great to learn from each other's expertises.
Yeah, thanks, Talk. So real quick, what are some of the indications that you know that engineers should take a look at to figure out that there's a memory leak?
Um, so its cases vary, but such as when you log out from, if you have the login and logout function, after the logout, open the memory graph debugger and see if there is the kind of suspicious or just the object is being located. You could see it on the left pane here. That might help. And that could just start digging more for to explore, see if there are any memory leaks or not. So I would say just you could start it from the left pane. Does that answer the question?
Yeah, and like, how often do you say that we should check for memory leaks?
I would say after before you submit the, if you working as a team before you push the project, I would run the manual test once. Then every time before push the source code. For example, if you're using the repository, if your team working with the repository before you push the repository, after you push before you publish the PO, you could just find out, you could just test on your end. That's my.
Yeah, okay, great, thanks.
I believe we have some questions from Andrew next.
Hi, Andrew.
Yep. Hi, Doc. Nice presentation. You kind of just answered my my question. I was just gonna say, like, what's a good way to be like proactive? So you just demonstrated a tool for identifying memory leaks after the fact. So my question was just gonna be like, what's a good way to be proactive about trying to like really avoid memory leaks in the first place?
Yeah, that's a good question. But yeah, I would say, for example, if you from my experience, the retain cycle is being kind of created when the escaping closure inside of the escaping closure. That's the most cases. So if you write in the self inside of the escaping closure, even if the closure is not escaping, you could just track down see if the closure is async closure or the sync closure. So that could help to prevent, at least prevent the self-referencing, self-reference circulars.
Great, thank you.
Thank you.
Hey, thank you, Takahiro. Well, thank you very much, Takahiro, for this great demo. In particular, I was really impressed by how the visuals come about in Xcode on the debugging there. It's very helpful. So thank you very much. And I want to remind everybody that we have our lightning talks every Thursday afternoon at 5:15 Eastern. Next week, our web engineer, Sydney So, will be talking to us about GitHub Actions. If you've ever used GitHub, the actions allow you to do some automation pieces and can be very useful. And thank you all for joining, and we'll see you next week.